Okay, so our 7.6 is just one objective. I believe there's only 3 or 4 examples in this section, but they're a bit lengthy, just like that last quiz question that we just reviewed. But let's jump into it. Let's first start off with some warm-up problems from an inequality perspective, just so you can familiarize yourself with inequalities. And then I'll remind you what happens when you divide or multiply by an inequality, or divide and multiply on both sides of an inequality. What happens to that inequality symbol? So for our first question, we're looking at 8 minus 2x is less than 12. Anytime you are dealing with inequalities, you sort of want to bring everything over to one side when you have like quadratic functions involved. But in this case, because it's linear, right? It's just x to the first power. We're just back to our whole combining like terms. So we have 8 and we have 12, which means let's use our inverse operations to subtract 8 from both sides. And then we have 12 minus 8 gives us 4. Now this is our first refresher. We're dividing both sides by a negative. So what happens to the inequality symbol? Yes, it becomes more than. It switches direction. 4 divided by -2 is -2. So our solution here is just all values of x greater than -2. We're done. And then that second warm-up problem is just asking us to put this inequality into interval notation form. And what I always like to do is I like to draw it out on a number line first so that I can really visually see what's going on. We have a -3 and we have a +5. Because that -3 is attached to an inequality that's underlined, are we going to have an open circle or are we going to have a closed circle? At -3, it's going to be closed because we're including that -3. What about at 5? It's open because we're not including 5. And so now we're going to ask ourselves, okay, we're looking at all values of x that are greater than or equal to -3, but, so greater than or equal to, but is less than 5. So that's our graph on a number line. And now from here, it's you're very much easily able to identify interval notation. You're including that -3, so it's a hard bracket. And you're going all the way up to 5, but you're not including 5, so it's going to be a soft bracket, aka a parentheses. And you're done. So that was our little warm-up problems. You guys have any questions? No? Okay. So we have a notes page defining what a rational inequality is, and then we can get into our first official example. I'm going to have maybe a student read this. Nishay, do you think you can read this for me?
We learned to solve linear inequalities after learning to solve linear equations. Techniques were very much the same, with one major exception. When we multiplied or divided a negative number, the inequalities are reversed.
Beautiful. Thank you so much. Yeah, what I highlighted in yellow is probably the key takeaway from that first paragraph. Dividing or multiplying by a negative, you really need to make sure that you reverse that inequality sign. And then we have our formal definition of a rational inequality, which is just any inequality that contains a rational expression, terms that have variables. So examples of that are what we have listed below over here. We have another notes page and another major definition, which is our whole critical number at the bottom. But let's see, James, maybe I'll have you read this whole section for me.
Rational inequalities means together with the following the sum of a quotient has an even number of negative factors and this value is positive. The quotient has an odd number of negative factors and then its value is negative.
Nice. This personally I find a little bit on the confusing end. It's good to know, but when we're working with rational inequalities and particularly solving them, we end up choosing test values. And as long as we're choosing the test values within the ranges involving our critical numbers that we'll talk about in a moment, you don't really need this whole thing. This is more to like answer a fill in the blank or a multiple choice question. And then let's see, Caesar, can you read this part for me?
We also must write the inequality which only one quotient on the left and zero on the right.
And then this last part.
Next, we determine the critical numbers to use to divide the number line into intervals.
Good, thank you. Again, you see quotient pop up a lot. Quotient is just dealing with the division of terms, but the most important takeaway from this slide is critical number, which I'll show you how to find through our example 1 in a moment. But it's essentially a number that makes that rational expression either 0 or undefined. We want to include both, not just what makes it 0, but also what makes that expression undefined. And so this slide is just the formalized step-by-step procedure in solving rational inequalities. But what I'll do for this first example is I'll write the step-by-steps on example 1 and go through it nice and slowly with you. Okay, so let's look at our example 1. We're asked to solve this in interval notation, and we're given x minus 1 all over x plus 3 is greater than or equal to 0. So the first thing that you want to point out is this inequality symbol. The fact that it's greater than or equal to 0, we're looking at all values that are positive or equal to 0, which means if we find a value of x that makes this rational expression equal to 0, it's going to be closed because we want it equal to 0. It's a closed circle, not an open circle. Okay, our first step in any situation with solving inequalities is to make sure that right-hand side is equal to 0, and it is, so we can essentially just move to the second step. So I'll make that as sort of like a side note. Always make sure right-hand side equals 0 before starting your problem. So now once we've established that, we want to identify our critical points. And once again, also critical points, critical values, critical numbers, they're all interchangeable to some extent. You'll learn about the differences, especially when you eventually take calculus. But at this stage, it's very much generalized. They like to use critical numbers. Okay. So what are critical numbers again? I'm gonna just repeat myself just so you can really get this definition ingrained in. But in this case, it's just the values of x that make this rational equation either undefined or zero. So the values of x that make a rational equation. In this case, it's an inequality, right? Undefined or equal to zero. Lucky for us, it's already factored nicely. So what makes it undefined? When our denominator is zero, aka when x is equal to negative, what makes it zero? Negative what plus 3 gives you zero? Negative 3. All right. How do we turn that rational expression into a value of zero? We look at the numerator. What makes the numerator equal to zero? 1. Good. So our two critical numbers are going to be negative 3 and 1. Great. We completed the first step. Now the second step, we want to draw out our number line and put our critical values on our number line. So we create our number line and put our critical numbers on our number line. Negative 3 here. We have positive 1 here. Now this is important. Once you get the hang of it, you don't have to write it down, but negative 3 was the value that made it undefined, which means that's always going to be an open circle, no matter what. Whereas the value that makes the rational expression 0, this is determined by what we have in purple over here. If it's underlined, then this is going to be a closed circle. And it is underlined, so we're going to have a closed circle at 1. But if it wasn't, let's say it was just greater than 0, then this would also be an open circle. So that's just something to be mindful of when you're solving problems like this. So undefined, it's always open circle. And the one that makes it 0, we look at that inequality. If it's underlined, it's actually going to be closed circle. Okay. So that's all we're doing for our step 2. Now step 3, what we're going to do is we are going to look at some test values between each of these ranges. So we're still going to utilize the number line, but let me just write the step below. So we want to pick easy numbers between negative infinity and negative 3, easy numbers between negative 3 and 1, and easy numbers or a number between 1 and infinity. And we want to plug it back in to our rational inequality to see what happens. Is it going to be a negative? Is it going to be a positive? What's going on in each interval? And so how do we write this? We are going to look at our inequality. I'm gonna write down what we mentioned here verbally, and then I'll mention the whole test values right below. So choose test values. It's going to be the second thing, but look at the inequality if it is underlined. We want to only include the critical number. Makes this inequality equal to 0. And then what I mentioned about choosing the test values, why don't we make that our fourth step? So choose test values between each interval. So that we can identify where it is positive, aka greater than 0, or negative, aka less than 0. So now let's do that. What's a value between negative infinity and negative 3? Negative 4, right? When we plug in negative 4 into x, negative 4 minus 1, is that a positive or a negative? It's negative. And then negative 4 plus 3 is a positive or a negative? It's a negative. What's a negative divided by a negative? Positive. Right, let's move to the next interval. What's a value between negative 3 and positive 1? Negative 2, or the easy one is 0. 0 minus 1 is a negative. 0 plus 3 is a positive. What's a negative divided by a positive? Negative. Let's move on to the next one. What's a value greater than 1? 2. 2 minus 1 is positive. 2 plus 3, positive. What's a positive divided by a positive? Positive. Now we ask ourselves, again, going back to the original problem, we're looking for all values of x that are greater than or equal to 0. Greater than 0, we have right here, right? AKA positive values. This is what we're honing in on for this particular question. So what intervals give us that positive marker? Our green highlighted section. And so this finally makes us arrive at our final and last step. I'm gonna just shrink this so I have a little bit more space, because they ask us to put this into interval notation. So our fifth and final step is we want to look at our interval values. Where our inequality is greater than or equal to 0, and then put this in interval notation. So we're looking at all values from negative infinity to positive or to -3, not including -3, union, all values from 1, including 1, so hard bracket, up to positive infinity. And that's it. Then we're done. This is our final result. So I took this example problem really, really slow so that you can understand the structure for each of the steps. But these next examples, I'm not going to be writing out the steps anymore. We sort of know it at this point. Any questions on this one? Okay. So now let's take a look at this second example and let's run through it a little bit faster now. So look at this inequality, less than 0, open circles for everything. Critical points. What makes it 0 or undefined when x is equal to 0, right? Look at that numerator, or 6. Great. Number line. Open circles at 0 and at 6. Choose test values, plug in. -1, we have a negative divided by a negative gives us positive. +1, we have a positive divided by a negative gives us a negative. And then value greater than 6, 10, we have a positive divided by a positive gives you a positive. We're looking for values less than based off of our inequality. Ooh, I made a mistake. What did I make the mistake at? It's not 0, right? We always need to account for this hint over here. What happens when I'm rushing? Okay, so we'll just bring this down for a moment. Still going to be open circles for all. But we need to subtract 1 from both sides. So we're essentially looking at 4x over x minus 6 minus 1 as a fraction is 1 over 1 is less than 0. Get that common denominator by multiplying by x minus 6 over x minus 6. So we essentially have 4x minus x and then plus 6 all over x minus 6 is less than 0. Combine some like terms. 4x minus x is 3x. So we have 3x plus 6 all over x minus 6. And then we can factor out a 3 from our numerator. So we have 3 in parentheses, x plus 2 over x minus 6 is less than 0. This does change our critical numbers a little bit. Our critical values are now -2 and +6. The -2 makes it 0, the +6 makes it undefined. But we're going to have open circles in both cases, either way. So on the number line, I'm just going to change that 0 to -2. And then we can plug in these values again. So let me just finish up this problem with you guys. Value between -infinity and -2. Let's choose -3. If we plug in -3, we have a negative in our numerator because -3 plus 2 is a -1 times 3 is a negative. And then -3 minus 6 is also negative. So negative divided by negative remains at our positive. Value between -2 and 6, let's choose 0. Get a positive in the numerator. We get a negative in the denominator. Positive divided by a negative is a negative. And then a value greater than 6, let's choose 10 again. We'll get a positive divided by a positive, which is once again a positive. So we're good. Now the last step is, again, we're looking at all values that make this less than 0. So all of our negative results, which is this middle guy. So in interval notation, this is simply soft bracket -2 to -6, soft bracket, and we are done. All right, any questions on this? I know we went about a minute over. I do have 2 more examples from this section. All right, so let's jump into example 3. Example 3, we already have that right-hand side equal to 0, so great. Let's identify the inequality. The inequality is greater than 0, so we're going to have open circles for all, and we're looking for intervals where it's positive. Now let's go ahead and factor that denominator. What are factor pairs of -15 that add to -2? We have a -5 and a +3. This is all greater than 0. Good. And so now let's look at our critical points. Critical numbers. And it's crazy. I shouldn't say it's crazy, but it's a little crazy in the sense that our expression can never be equal to 0, which doesn't matter in this case because there's no underline here. But why can it never be equal to 0 is because we have that constant in the numerator, which is what I have mentioned a few times throughout our past lessons. So the only values that are our critical numbers are -3 and +5. And these values, none of them would make it 0. They would just make our rational expression undefined. Now we're ready to draw out our number line, looking at values from -infinity to +infinity, inputting in our critical numbers and identifying that they're going to be open circles for both because our inequality is not underlined. And now let's choose our test value. So what's a value less than -3? Let's do -4. Let's plug this back in. So our numerator is 5. So it's going to stay positive throughout each of these testing of our intervals. But in our denominator, we have -4 minus 5 is a negative. And -4 plus 3 is also negative. Negative times a negative is a positive, and a positive divided by a positive is a positive. What's a value between -3 and +5? 0. 0 minus 5 is a negative. 0 plus 3 is a positive. A negative times a positive is a negative, and a positive divided by a negative is a negative. And then what's a value greater than 5? Let's choose 10 again. 10 minus 5 is a positive. 10 plus 3 is a positive. Positive times a positive is a positive, and a positive divided by a positive is a positive. We're looking for values that are greater than 0, aka that are positive. So these are our 2 intervals that we're looking at. And so finally, let's put this all in interval notation. We're looking at all values from -infinity to -3, closed. It's an open circle, so it's soft bracket, aka a parentheses, union, soft bracket, or a parentheses, 5, comma, infinity. And this is our final result. All right. Let's move on to our example 4, and I believe this is our last example from this section. And so once again, we want to make that right-hand side 0. That's our first step in all situations. So we're going to subtract both sides by a 5 over 3x. And when we do, we are looking at 1/3 minus 2 over x squared minus 5 over 3x is less than 0. So essentially, we're going to look at all values that are negative between intervals. And a note, we're going to have all open circles once again because there's no line underneath that inequality. That left-hand side, though, we're going to have to find a least common denominator between these 3 fractions. And so our LCD between 3x squared and 3x is simply 3x squared. Now let's multiply by some fancy forms of 1. We multiply that first fraction by x squared over x squared, second one by 3 over 3, and that third one by x over x. So we're essentially looking at x squared minus 6 minus 5x, all on the numerator, all over 3x squared for that least common denominator is less than 0. And now we can factor out that numerator. I'm going to put it in to descending form so that you can clearly identify, oh, okay, what are factor pairs of -6 that add to -5? We have -6 and +1. And so now we're very easily able to identify our critical numbers at this point. Again, values that make our rational expression equal to 0 or undefined. And so we have -1 makes it equal to 0. 0 actually makes it undefined. And then we have a +6 that makes it equal to 0. So I'll just make a pointer here. That 0 is what makes this rational expression. Undefined. Not really necessary to know for this particular example because we're going to have all open circles anyway on our critical numbers. But if we ended up having an inequality that was underlined, then you know that that would be the only open circle. And so now let's put in our critical numbers. We have -1, we have 0, and we have 6. Again, all open circles. Let's choose our test values and plug them back in. Value less than -1. Let's choose -2. -2 minus 6 is a negative. -2 plus 1 is a negative. And then we have -2 squared ends up being a positive. Negative times a negative is a positive. Positive divided by a positive is a positive. What's a value between -1 and 0? We have -1/2. -1/2 minus 6 is a negative. -1/2 plus 1 is a positive. And then -1/2 squared times +3 is a positive. Negative times a positive is a negative, divided by a positive is a negative. A value between 0 and 6, let's choose 1. 1 minus 6 is a negative. 1 plus 1 is a positive. And then 1 squared times 3 is a positive. When we simplify this, we get a negative divided by a positive, which is a negative. And then last but not least, we have a value that is greater than 6, which is, I don't know, let's choose 10. 10 minus 6 is positive. 10 plus 1 is positive. And then a positive times a positive is a positive, divided by a positive is a positive. Once again, what are we looking for? We're looking for values that are less than 0, so that are negative. And so, how do we represent this in interval notation? We're looking at soft bracket, aka parentheses, -1, comma 0, soft bracket union, 0, comma 6, soft bracket. And we're done. That completes this problem. So these are just some additional examples to further enforce your knowledge and understanding of solving rational inequalities. Highly, highly, highly recommend that you do them just because this section is very systematic and structured. Once you get the muscle memory of the steps that you have to run through, you'll get every single question correct in this section. Hope this was useful. Next time, we will be jumping into chapter 8, and we're almost near the end of our entire curriculum. We have chapter 8, chapter 9, and then we're done. So let me know if you have any questions, and I will see you guys next time.